Welcome friends to KCSE 2018 Paper 1. This is question 19. It is under differentiation calculus application. The distance covered by a moving particles through point O is given by equation. You can see the equation there. T cubed minus 15t squared plus 63t minus 100. Find the distance covered when t is equal to 2. This is just a matter of substituting t, the value of t in the equation. Therefore, we say that the distance s, because it's the displacement, distance and displacement are the same, is equals to 2 cubed minus 15, 2 squared plus 63, 2 minus 10. You see, anywhere that there is t, I've just substituted 2. Therefore, there my answer becomes 64 because it is distance we take, it is meters. The unit, you can just say 64 units, still no problem. Part B, you are told the distance covered during the third second. Now, this is the distance covered during the second, the second second. So, we can look at the third second. So, on the third second, you just do the same thing. We are going to substitute 3 in the part of t, the time. So 15 into 3 squared plus 63 into 3 minus 10. So during the third coverage, this was 71 meters. However, we have not answered our question because this is the whole journey from 0 to 3, or whenever it was starting, the first, second, and the third. But during the second, the distance covered during the second minute was 64 meters. So in just a small sketch, if this is the second and here it is the third, and during the second it has covered 64 meters, during the third it has covered 71 meters. So the distance covered in between here will be 71 minus 64, which we have 7 meters covered during the third second. So the transition from the second to the third, it was 7 meters. Next, we are told the time when the particle is momentarily at rest. So when the particle is momentarily at rest, it means that the velocity is equal to 0. And we have now to differentiate to take change in t over change in s. Differentiating the whole equation from here. How to differentiate? We are taking the value on top, we multiply it at the bottom. So we'll have 3t for that first part. Then on the upper part, we subtract 1. So we have 2. Minus 2 times 15, that is 30. I remove 1 from 2, it becomes only 1. Then the other one, because it is power 1, I just remove 1 times 63 to 63. Then 63 minus 1 minus 1, it is 0. So therefore, I'm going to be left with this equation. So this is the equation I'm going to substitute is equals to 0. And if you look at it, it is already forming a simultaneous equation. I'm going to use not a simultaneous equation, a quadratic equation, and I'm going to use quadratic formula to solve it. Minus b plus or minus the root of b squared minus 4ac over 2a, where this one takes the position of a, negative 30 takes position of b, and positive 63 takes the position of c. So if I substitute, I'll have negative, then negative 30 plus or minus the root of 30 squared, that is 900, minus 4 times 3 times 63 over, because a negative and a negative takes the position of a positive, 2 times a, which is 2 times 3. Now we have 6. Now on the upper part, I will be taking 900 minus all of this, find the square root, it is positive 30 plus or minus 12, then divided by 6. Therefore, it means that the time when it's at rest 1, 30 plus 12, it is 42 divided by 6, that we have 7 second. And we also have 30 minus 12, that is 18 divided by 3, which is 3. Divided by 6 is 3. So it means that during when the particle is momentarily at rest, it will take 7 and 3 seconds. 7 seconds or 3 seconds. Next, we are told to find the acceleration when t is equals to 5. So to find acceleration is simply, you are going to differentiate again the velocity, because if I have s, you differentiate, you get v, differentiate v to get a, acceleration. So we are going to say that because we have the equation already here, just take 2 times 3, that is 6. Then you subtract 1 as the norm, it remains t. Then also it is t power 1, so 1 times 30, it is 30. 30, then 1 minus 1 is 0. So this is the acceleration. So to find acceleration, we'll say 6 into time, we have been told it is 5, minus 30. So 6 times 5, it is 30. 30 minus 30 is 0. Therefore, the acceleration took 0 meters per square second. Or you can say that the acceleration was in constant motion. So that is how the question is tackled under application of differentiation. If you have any question, write it down in the comment section. Follow me on my YouTube channel to get access to more of such questions. Thank you very much.